Take your seats, please. My lecture will be about 40 minutes. And after that, I will give anyone the opportunity to ask me questions for about 15 or 20 minutes. So the whole thing will be 1 hour. And it is after that hour that we will do book signing. You can buy the books there if you want to, and I'll sign them here. We'll get back to that later. Pendulum. And suppose I bring the pendulum all the way out here. We call that the amplitude of the pendulum. And we let it swing back and forth. There's a certain period. But now, we bring it out only this far. It doesn't have to travel very much at all. Doesn't that make a difference in the period? The equation says no, it doesn't. Because if it did make a difference, there would be in that equation the amplitude, which is not. And I'm going to demonstrate that to you, that it is quite remarkable that indeed that period is independent of amplitude if you don't go to extreme values of the amplitude. There's something else in the period, but the equation says, sorry, it doesn't. And I'm going to demonstrate that to you too. We have here, by the way, if you ever want to test this pendulum, this equation for yourself, put in L equals 1 meter and use this number, you will get a period of 2.0 seconds. It's very easy to do at home. You make one meter, you put an apple at the bottom, and you swing it. The 1 meter has to be accurate. You see that it's going to be 2.0 seconds. Our pendulum that we have here is really the mother of all pendulums. Look at it. 15.5 kilograms, and the length of this pendulum is 5 which is my reaction time. How accurately am I able to make that measurement? That has nothing to do with our lack of knowledge of the exact length. Now, the last time that I gave this lecture with the pendulum is 12 years ago. I was 63. And at that time, I told the class, my reaction time is 1/10 of a second. And it was. But now I'm 75. And so my reaction time is no longer 0.1 seconds. What is it? Well, I do not know, but I have a feeling that if you want to be kind to me for a change, let us assume that my reaction time at age 75 is now 0.2 of a second. So if you can live with that, then every measurement that I make, no matter how long it is uncertain to 0.2 of a second. Do not confuse that with that 0.02. That has to do with the length. All right, all of you can see. And here you see the pendulum. And I have 2 marks on the floor here. If I hold the bob here, then it is 5 degrees. This is 5 degrees. And when I hold the bob here, it is 10 degrees. Timing is not easy. The best way to do it is to start the timing when the pendulum comes to a stop. That is rather well defined. And then you let it swing 10 times, and then when it comes to a stop, you stop it. And it would help me if you would count how many oscillations we have made. Because then I don't have to look at it. All I have to do is when I come close to 10, I have to watch for the moment of stopping, and then I will end it. So, we'll do this first at 5 degrees. I'm going to start it when it comes here. Yeah! Okay, now you count. You're doing very well. You're going to pass this course. tenths of a second. Don't count on it because you haven't seen the rest yet. So, now 10 degrees. That moment is crucial. That moment is crucial. That's where you can lose 4/10 of a second, and then you look like an idiot in front of your students. Yeah! That we have to change the mass of this object. And the way that I'm going to do that is prominently demonstrated on the cover of my book. Yes, I'm going to hang on that pendulum. It is a difficult demonstration. First of all, it is painful. It really is. Second, the timing is tricky. Because when you look at a pendulum and when you see it stand still, you know, that is really well defined, plus or minus 0.1 seconds. When you are swinging yourself, however, then you can only do it by sensing the moment that you think you stand still. And that's what I will do. And then you will do the counting. And this is very unpleasant. It is. Oh, there's something else I haven't told you. If you're a good physicist, you will say, if you're going to sit on that bulb, then effectively you bring the mass of the bulb up, and so the length of the pendulum will shorten, and so you get a shorter period. And I know that too. Therefore, I will have to stretch my body so that when it is here, that it is almost completely parallel to the floor. If I don't do that, I will not be able to convince you that the period is independent of the mass. And that makes it very difficult for me. So I will start it at some moment, you will see when, and then you do the counting. Are you ready? Okay. Yeah! You count. You ready? Okay. Oh, this really hurts. Can't you count a little faster?